Yes, sir. Okay, so I'm going to look at the first practice problem, and it talks about David and Goliath. And it tells me in there that the frequency is 100 revolutions every minute or every 60 seconds. So that's the frequency. So the frequency divides out to be 1 2/3 revolutions per second. Okay, so I got the frequency to be 1 2/3 revolutions per second. Now I need the period. The period is the inverse of the frequency. So 1 2/3 is what? 5/3? 1 over 5/3 is going to give me 0.6, and it'll be in seconds. So there's number 1. Not too tough. Number 2, I have an ant on a blade, and they give me some information. They tell me that the radius is 0.8 meters, that the frequency is 1.2 hertz, which is 1.2 cycles per second, and they want to know how fast does the ant spin. So if they're asking me how fast the ant spins, then they're asking me for the speed of the fan blade. So I have V is equal to 2 pi r over T, but that's really the same thing as 2 pi r times 1 over T, and that's the same thing as frequency. So I can really rewrite it as 2 pi RF. So now it's a piece of cake. I know 2 pi, I know my R is 0.80, and my frequency is 1.2 cycles per second. So now I'm simply going to multiply 2 pi times 0.8 times 1.2, and I find out that if I do that correctly in my calculator, my speed is going to wind up being 6.03 meters per second. And then part B says, well, if he flies off the fan blade, what will be his path? Well, the fan blade is turning around like that. So wherever he leaves, he's going to head out in a straight line. If he falls off here or flies off here, it's always going to be tangent to the point that he was released from. Okay, let's go on to number 3. Number 3 says a toy airplane, much like you did in the lab, flies around and around in a circle, mass of 0.145 kilograms. And we know that the circle makes a radius of 1.2 meters, and it makes a circle every 3 seconds, so the period is 3 seconds. All right, so that's the given information. Part A wants to know the period. Well, we just told you that it was 3 seconds, because it makes one circle every 3 seconds. Part B says the speed of the airplane. Well, speed is equal to 2 pi r over T. So we have 2 pi times 1.2 meters over 3 seconds. So that's going to give us 0.8 pi, and 0.8 pi is 2.51 meters per second. That was not hard. C says the centripetal acceleration. Well, centripetal acceleration is b squared over r. So now I have 2.51. Don't forget to square it. And my radius is 1.2 meters. So now I just plug and chug, and I do that to give me 5.26 meters per second squared. Very much like what you did in the lab. And then D wants to know, what is the centripetal force acting on the plane? Well, centripetal force is equal to mv squared over r. They gave me the mass, 0.145 kilograms. And the speed was 5.26 meters per second squared. So if I make that multiplication happen, I get 0.76 newtons. Now we needed to look at the angle for this one. So I'm going to take you through what I'm going to do in terms of how I derive the equation. Here's my weight. There's my mgy and my mgx. I'm looking for that theta. This is my force normal. So my force normal is equal to my mgy. So I know that if there's friction here holding it in place, that it begins to slip, then the friction will equal mgx. And the friction is mu times force normal equals mgx. Well, mu, force normal, is mg cosine of theta. And mgx is mg sine of theta. So mg's will go away. So mu is just going to be sine theta over cosine theta, which is the tangent of theta. They told me mu was a value of something that I don't know. So now I got to play with that. So that is not at all what I should have done on number 5, so number 4. So that's kind of goofy, but that's a good thing to know. That equation is still a good thing to know. All right, so what I need to do is I need to go back and figure out how to work it with the correct thing. So let me stop for a minute and gather my wits, and I'll. All right, now let me see. I got a good diagram going on. Let me see what I can do with this one. The last one I tried to do it with friction. You didn't even have any friction, so it told you not to rely on friction. So that was kind of goofy. Okay, so the force normal in the x direction is pointing toward the center of the circle, so it's going to supply the centripetal force. So the force normal in the x direction is going to be the force normal times the sine of theta, and that's going to be my centripetal force. Now, I need an expression for my force normal. Well, I know that force normal in the y direction is the same thing as mg. So if you look at that diagram, this vector and that vector are exactly equal but opposite directions. So this is going to be the cosine of theta times the force normal is equal to mg, or the force normal is the same thing as mg over cosine theta. So force normal, right here, I'm going to substitute this in for force normal. So I'm going to have mg divided by cosine theta times sine theta over 1 is equal to mv squared over r, my centripetal force. Masses will cancel. Sine theta divided by cosine theta is called the tangent of theta. So the tangent of theta times g is the same thing as v squared over r, or tan theta is equal to v squared over rg. Well, they tell me v squared is 25 meters per second. Don't forget to square it. The radius of the track is 250 meters per second. 250 meters. And gravity is 9.8. So I can do that math, and I'm going to find out that theta is 14.31 degrees. Okay. Number 5, I wrote down all the givens because I didn't want to run out of time. So now I want to find the orbital speed of the Earth. So I know that the speed is just distance over time, 2 pi r over capital T. R of my orbit was 1.5 times 10 to the 11th meters. And my T was 31,536,000 seconds, because I don't want it in days anymore. So if I do that math correctly, I got my orbital speed to be 29,886 meters per second. And then part B says, well, that's great, but what's the mass of the Sun? Well, I know that between the Earth and the Sun, there's a gravitational attraction. Mass of the Sun, mass of the Earth, over the distance squared. And that's equal to the centripetal force acting on the Earth, so mb squared over r. So my masses in my Earth are going to cancel out. This r and this r will decrease, and I'll have a denominator with only r in it. So I want the mass of the Sun. So I'm going to say the mass of the Sun is the speed squared times r over big G. Now, I already know everything, so the mass of the Sun, the speed was 29,886 meters per second. So there's my speed. I'm going to square that and multiply it by the orbital radius, which is 1.5 times 10 to the 11th. And that's simply the distance from the center of the Earth to the center of the Sun. And big G is our 6.67 times 10 to the negative 11th Newton meter squared over kilogram squared. So the mass of the Sun is 1.99 times 10 to the 30th kilograms. Okay, number 6 does not give you a whole lot of information. To give you the radius, and that's about it. And they want to know the minimum speed. Well, if I'm looking for the minimum speed, I want the tension in the rope to be 0. I want it to be slack, in other words. So the only thing that's applying the centripetal force is the force of gravity, which is mg. So big G, m1, m2 over r squared. Sorry, that's not what I wanted at all. I'm going to get rid of that. I wanted the centripetal force equation, so I should have said mv squared over r is equal to mg. So since there is no tension to worry about, I can say that v is simply the square root of rg. So that's why they didn't need to give me much information. So I have 1 meter times 9.8 meters per second squared. And I want to take the square root of that. So v is going to be equal to 3.13 meters per second. Okay, so next one, number 11, I have all my information given. I have a mass that's being moved in a horizontal circle with this radius with that speed, and they want the centripetal acceleration. So that's just v squared over r. So I'm going to have 6 meters per second over 1.5 meters. So that's 36 divided by 1.5. And if I did that correctly, then I should get the centripetal acceleration is 24 meters per second squared. Now, they want the tension. Well, the tension, since it's a horizontal circle, is what's supplying the centripetal force, so that's mv squared over r. So centripetal force is equal to tension is equal to 0.3 kilograms times 24 meters per second squared. So the tension is simply going to be 3/10 of 24, which is, I believe, 7.2 newtons. And we're done with number 7. Okay, number 8 is very similar to number 1. You have a fly sitting on the edge of a fan blade, and the fan blade is going 100 revolutions per minute, and they want to know the period of the motion of the fly in seconds. So 100 revolutions per minute is also 100 revolutions every 60 seconds, and we already said in number 1 that was 1 2/3 revolutions per second. And the period is the inverse of the frequency. So that's 1 over 1 2/3 revolutions per second. So we're going to get 0.6 seconds per revolution. So there we go. Okay, well, I listed my given as I'm looking for my radius, and I have v is equal to 2 pi r over t. But I don't want that. I want to bind r, so velocity times the period divided by 2 pi should give me the radius of the pinwheel. Well, I don't have the period, I have a frequency, but I know that I can take the frequency and inverse it and get the period. So 1 over 120 revs per second is going to give me my period. So I'm going to go back over here and say, well, 15 meters per second times 1 over 120 divided by 2 pi will give me r. Now be careful with that 2 pi because you want to put that in parentheses, because if you do 2 and then divide by pi, it'll mess. I mean, if you just do 2 pi, it'll divide by 2 and then multiply by pi and give you a bad answer. You're welcome, babe. All right, so then I do the math there and solve for my radius, and when I did it, I got the radius to be 0.1194. If yours is different than mine, be careful with that pi. Put it in parentheses, because if you don't, like I said, it'll divide by 2 and then multiply that answer by pi, and that won't work.